Welcome everyone to Will Epperson's Thesis Defense. I'm Dominic Moritz. Together with Adam, we were co-advising Will since 2020. It was an interesting time to start both for me a faculty position and for Will to start a PhD position because we were doing all of this remote. And so we didn't meet until probably a year later. So yeah. And our time to start, but despite that, yeah, Will has done fantastic things over the last few years, and I'm super excited to, for him to have grown as a researcher to the point of presenting his thesis defense today. Welcome everyone, friends, family of Will, and other researchers. We have the whole committee here, so that includes hearing from Sherry, who's remotely calling in. We can't see you wave, but she waved to us, so I'll wave.
I'll put him on the screen here during.
Gagan, who's also here, and then Nikki, Adam, and me. All right. So the way this is going to work is that Will's going to present his thesis work, defending it to the committee, which is going to be about 45 minutes, an hour or so. Then we'll have questions from the committee. We have a tradition at CMU where we go by distance, starting with the furthest, which I think in this case is Sherry. Yeah. So Sherry, you can be prepared to ask the first questions, and we'll go through the committee. Once the committee is okay with questions and has sufficiently attacked Will, we'll open it up for questions to others. Then we'll have a closed session, so we'll have to leave, and then the committee will retreat. And then you'll either see white smoke or black smoke. We've decided. And with that, I'm super excited to hear your thesis.
Awesome. Thank you. Awesome. Thank y'all. Thanks for coming. My name is Will, and I'll be presenting my thesis today on interactive data profiling. So nowadays, we see data everywhere, where it's driving decisions and powering intelligent systems in a lot of domains. We see data being used in healthcare to model patient outcomes, and technology to understand user behavior, and in business to understand current trends and predict future trends. Maybe. Thanks, Adam. So we think a little bit more about how this works in practice. We have people from a lot of different roles, like data scientists, data engineers, and AI engineers that use programming to clean their data, train models, and explore results. To make this more concrete, let's imagine that we have this data set of around 5,800 paper abstracts and metadata from data visualization conferences. So you have information like the abstracts in each of these papers, the title, the authors, the year, and so on. And there's a lot of potential analysis and modeling goals we could do with this data. For instance, we could understand what are the common research topics, authors, or venues. We might want to classify these abstracts based on the text, or we could fine-tune a large language model to write abstracts in this particular style. But before we can do this, we need to actually figure out, is this data set usable for this task, right? What is actually in this data, and can we even answer these questions with the data that we have? And this is the goal of exploratory data analysis and data profiling, where we can examine sample values, summary statistics, and summary visualizations to profile the data set to get an overview and gain new insights about the data. This is important both to understand the data, but also to notice potential issues, because a lot of data issues are silent. I mean, I could still train a model on the data, I could still run an analysis, but the correctness really depends on understanding the data and its limitations. So for instance, with this abstracts data, we might want to understand what are the actual conferences that are included. If we want to use this on a set of conferences that we don't actually have, then this probably won't work very well. The same with years. We want to understand how far back does this data go, or do we have data from the past couple of months or from the year 2025? We want to check quality issues, like are our titles unique? Do we have duplicate data? Particularly if we're going to use this for training some sort of model, we want to be sure that this is actually a unique set of data. Or are we missing any data? Does our abstract have any missing values? There's a lot of other potential threats to validity of models and insights that are based on this data. And we can't answer these questions just by looking at the table. We need to write extra code to actually profile this data set and answer each of these questions. So we can do this pretty easily for a single chart, right? We could use the Altair library to get this chart that shows us, okay, we actually have 6 conferences in this data set. So these papers are coming from mostly the Viz conference, followed by Euroviz and so on. But this is just one of the attributes, right? We want to do this for every attribute in our data set. We do this every time we update the data set as well. So in practice, this makes EDA very slow and tedious to manually profile every aspect of our data set, every iteration as we're updating and working with this data. And this is critical because analysis really depends on human expertise to understand the data in the current analysis context, right? If I'm using this data set for looking at these 6 conferences that I have, then it'll work great. However, if I'm trying to use this for conferences that I don't have the data on, then that context won't actually work with this data set. And we see this beyond just the single data set in a lot of surveys of data scientists where they self-report spending almost half their time just on data cleaning and visualization. For instance, the survey from 2020 from the Anaconda Foundation. And that data quality issues are consistently undervalued in model development pipelines, which can lead to poor model performance and adverse consequences when people don't necessarily understand the limitations of their data ahead of time. So in an ideal world, what this looks like is that we'll start out our process with acquiring a new data set, like this data set of paper abstracts. Then we'll go through this process of exploring the data. So we'll use graphical methods like the one that I just showed, or non-graphical methods like just computing summary statistics. And then we'll move on to a downstream task, like predictive modeling, training a model, running a hypothesis test to actually see is there statistical significance, or other downstream tasks. This is a super iterative process. Right, I'm not just going in one direction, but as I learn new information by exploring my data, I might go get more. As I train a model, I need to explore the results. So this is a super cyclical and iterative process. However, the fear is that since actually understanding the data is difficult, it's easy to skip over this process of EDA and never build understanding of the data. I think part of what we need are exploration tools that actually meet people where they work. And nowadays, when working with data and data science, this is in computational notebooks where people can program because they really support the iterative workflows that are characteristic of data programming. So what this looks like is I have a notebook where I can write code, write small bits of code, and then incrementally execute this and look at the results in between. We can use this rich ecosystem of libraries that we have in Python or other languages for data manipulation, data visualization, or AI and machine learning. So I wanted to better understand what do these iterative workflows look like in practice? And in particular, this aspect on what does this repetitive coding look like in practice? Like there's a lot of repeated tasks that people seem to be doing. So we wanted to better understand how are people reusing past analysis code. So this was an early study that I ran in my PhD where I ran an interview study and a survey with 149 data scientists at Microsoft. So I'm going to go over the results at a very high level just to motivate, I think, some of the systems I'll introduce later in this thesis. So in practice, we found, unsurprisingly, that data exploration is highly repetitive. There's often people are looking at the same things while they're exploring data. However, it's really critical that even though people are repeating work, that they have this ability to customize. So one of the strategies that we found people using was they would create these template notebooks, which have a lot of the common steps for a task like EDA. However, they would need to tweak parts of this, right? So they wanted both the ability to automate part of this, but also have the ability to ask follow-up questions in a programming environment. So I think this outlines an opportunity for using lightweight programming tools that automate some of the common EDA steps, however, without having to leave the programming environment where I can also do this customization and follow-up. But we can think about tools that exist to help automate some of these repetitive tasks. And prior research has shown how this kind of exists on this spectrum, from full user agency on one side to full automation on the other, where the sweet spot here is really somewhere in the middle, where we can save people time during analysis and guide them towards interesting observations. However, users still can maintain control and customize and ask follow-up questions as much as they need. And we've seen a lot of prior work that I think exists along the spectrum. For instance, there's this rich ecosystem of very customizable libraries where there's full user agency. So these are highly expressive, where a user can manipulate data and create custom visualizations. However, this takes effort, right? Users have to learn a new syntax, they have to learn how to use the library, and they have to write code, like I was talking about earlier, for every new visualization. On the other hand of the spectrum, we have some tools for automatic visual data exploration that automatically show charts. However, these aren't necessarily integrated into the programming environment, so it requires context switching from when I'm actually exploring my data in a programming environment to this tool that can help me make sense of it. And these are harder to customize and ask very specific follow-up questions that I might find in the tool. Now, there has been prior work on this idea of integrated data exploration, where I can do this within a programming tool, tools like Pandas profiling or Lux. But these often show too much information to actually help people do this quickly. So it still makes the process slow and manual since there's so much information in these systems to actually sift through. So I think our goal here is to be somewhere in the middle. We're on one end of the spectrum, we're doing manual EDA through code, which is very customizable, but it's slow. And on the other end, we have these entirely automated systems that can be rigid because I don't have the customizability that I get from a program environment. So this brings me to the approach I've developed in my thesis for interactive data profiling. And the core question I've tried to investigate is how can we build flexible and lightweight systems to help people more quickly understand their data. And I've created 3 systems that try to create this fast feedback loop in between interacting with data and then visually understanding the results. So first, I'll talk about AutoProfiler, where we can provide fast feedback with automatic updates while someone's programming with their data. Next, the SOAS system, where we can adapt these data profiles based on a user's analysis history. And finally, Texture, where we can interactively define and explore data profiles and show how we can extend this idea of data profiling to text. And this core approach of using a fast feedback loop has really informed some of the other work I've done during my PhD on quick dashboarding and AI agent debugging. However, I'm really going to focus on these 3 systems today because I think that they really cover the core of the approach. So first, I'll talk about AutoProfiler. And this is an open source system and was published at Viz a couple of years ago. So AutoProfiler introduces this idea of continuous data profiling, where we can directly augment the programming environment to show profiles that update as the user programs. What this looks like is that as a user transforms their data with code, we want to automatically visualize the results to enable this fast feedback loop. So I'm going to walk us through a very quick example analysis where we can show how AutoProfiler helps automate some of the steps of EDA so we can more easily understand the results as we program. So I'm going to return back to the data set I was talking about earlier. And our goal here with this paper abstracts is to understand which paper in this data set has the most citations. So we have a traditional computational notebook environment on the left and the AutoProfiler system that's in situ in the notebook on the right. So what this looks like is that as soon as I execute this code, we'll get this data profile for the data that's in memory. So we can look at our data frame DF and start inspecting the columns. For instance, we can look at the conference and see these 6 values that we talked about earlier and their distribution. We could look at the years to see what's the actual distribution of years in this data set and see the range of the years. We can look at the titles, and here we might actually notice a quality issue where we have some duplicate titles in this data set, right? These top 2 titles have a count of 2, which might be a quality issue that we need to fix later on. We can keep going through our data set to quickly inspect the rest of these attributes. But we might notice that we don't actually have a citation count column. So what we need to do now is actually load a new data frame that we've gathered from the internet and then join it with this data frame. This is a very common task in data analysis where we're combining data sets. So what we'll do is we'll execute this other bit of code. Then as soon as this is executed, we'll have this new data profile for the new data frame that's in memory. We see that it has the title, which is great. So we can join these 2 data sets based on their title. We also notice there might be a quality issue in this title where we have duplicates, so we'll need to get rid of that. And then we also have this column of the citation counts, which is our main goal, right? To understand this distribution of citation counts. We see this visualization where we see it has a long right tail, which makes sense for our citation counts. Most papers have a small number of citations, and then there's a couple outliers that have really a lot of citations. So what we're going to do now is show we can use AutoProfiler to actually keep manipulating our data through code and then inspect the results. So I'll copy and paste some code in, or of course nowadays I could use AI to write this, but I'll execute this code where we're going to drop the duplicates that we found in our data set and then make the title lowercase. So this was very fast. We see as soon as this was executed that the data profile is updated. So now I can inspect the results to make sure that this was successful. So now I see that I have unique titles and they're all lowercase. So now I'm ready to join these 2 data sets together so I can actually answer my initial question. So we'll paste in another line of code here to join these 2 data sets based on the title. And then once this is executed, we see that this new attribute in our original data frame, the citation count, is now included in the data profile. So this is the same distribution as before, and we can see like how this column is distributed. We can also see that not all of our papers matched in this data set. So 39% of the columns, 39% of the values are missing. We also have this interaction where I can click on part of the visualization and it'll write code on my behalf. And now I can actually go and inspect the data. So I can actually answer my original question now because I have this new attribute where the most cited paper here is the D3 paper. And so we're able to go through this process of writing code and then inspecting the results in AutoProfiler, and they get this fast feedback loop. So what this shows is how we can use these automatic data profiles to enable fast feedback while programming with data. But we didn't have to write extra EDA code, right? We were able to see these overviews without having to write extra code to actually understand this. And we found in studies that this held true with users as well. So we ran this lab study, and we found among 2 different versions of AutoProfiler that 91% of the reported insights came from the tool rather than the user writing extra code themselves. As one of our participants said, I would probably try to do similar things that AutoProfiler suggests, but it would take a much longer time. Like the amount that I did in 30 minutes, if I had to do it without AutoProfiler, it would have taken hours. So they were able to really speed up their analysis loop without having to write this extra code every time that they update their data. We also ran this deployment study over a 3-month period, where we really found that Autoprofiler was able to facilitate this idea of serendipitous discoveries. So this is kind of a long quote, but I think it's interesting, so I'll read it out. And one of our participants said, one of the things they very often notice is if the histogram is completely flat. That means that either all the numbers are exactly the same or that it's some sort of sequential number. Sometimes that's what I'm expecting, so great, but sometimes if that's not what I'm expecting, then that immediately stands out as being weird and draws my attention to it. I would never have noticed if that were not plotted. I would never have thought to plot it. So it shows how when we can automatically show people information about their data, they might make insights that they didn't even know to look for otherwise. So the core of this approach in Autoprofiler is to show automatic data profiles or even basic data overview information can help people quickly understand each iteration of their data set. So we're interested in how we might extend this further, and in particular, go from these generic overviews that update quickly to this idea of a task-specific data profile. So for instance, a lot of times during a data analysis, we're doing the same thing over and over. Like we're filtering our data, as I showed in that last example. I might filter to the papers with the top number of citations, or I might aggregate my data, where I'm going to get the number of papers per year. And for each of these tasks, there might be specific ways we could visualize the data to help people understand it more quickly. And this is the idea that we explored in Solus, which was published at Euroviz a couple years ago, and we also have an open source system for it. So Solus shows how we can use this idea of adaptive data profiles from the analysis history to create a more task-specific data profile. So what we do is we track the code that a user writes, their interactions with the data through their code in this history to do two different things. The first is that we create these task-aware data profiles. The next is that we model the user column interest from the actual code that they're writing. I'm mostly going to talk the first one today, just for the sake of time, but I'll kind of allude to how we can do number 2 as well. So what Solus does is it's tracking the code that user writes to understand the provenance of their current data. So what provenance means in DataViz is basically just where did this data come from? So every time we do a column reference, a column assignment, call the value counts, describe, or any of these functions, rather than just getting a generic data set back, we know that the data came from this particular function. We can use that information to visualize the data and show a more specific encoding. So as an example of what this looks like, since Solus knows the semantics of the data from code, when I apply a filter, for instance, we can go and access this unfiltered data to show the background distribution. So once again, we filtered to the papers with a citation count greater than 100. And I can better contextualize this data by showing the background. For instance, we can see that this is actually a very small sliver of the data in blue relative to the background. We see in the conference that we show both our background data and this filter, and the same with year. And this extra context helps us understand that actually in this data set at least, none of the top cited visualization papers are coming from Euroviz or CHII. And we wouldn't have been able to make this insight without also seeing the background distribution. So what Solus's approach looks like, in Autoprofiler, we're always profiling the data that's currently in memory. So as soon as I execute code, I'll show this overview for the data in memory. So I'll execute df, and I'll show you this overview of the conference. Then once this updates, once I apply a filter, we'll re-execute this profile. So now I see this new profile of the conference attribute, but I lose this background information. This is different than Solus, where we're tracking these past iterations of the data, where as we execute a new bit of code, we can use this background context. For instance, as I showed with conference, we can show the background information. So we do a couple things in this approach, right? This first is these task-specific visualizations. And we do this for 5 different analytical tasks. So I only showed a demo of the filters, but we do this for describe, correlation, group bys and aggregates, null checks, and filters. And for some of these with filters, we're actually using the same type of overview visualization, just adding extra information. For some of these, we can use a totally different type of visualization. Like for describe, we're going to show box plots to overview the visualization, or overview the data. The other thing we can do with this is rank profiling visualization. So like I said, I'm not going to talk about this super in depth, but as a user interacts with their data through their code, we can start to build up this analysis history to rank these charts that I showed by those that we think will be most relevant to the attributes that they're currently interested in. So the benefit of this is that we get even faster feedback. Since we know the task that someone's trying to do, we can show this overview visualization that provides faster feedback. Of course, Solus has a downside is that we actually have to manually create these visualizations per task and then manually map the code to the task. In an online survey evaluation, we found that for the majority of tasks we evaluated, the data profiles shown in Solus were significantly preferred. So at least for the describe, correlation, and group by visualizations, people significantly preferred the Solus overview. For the null visualization, people were ambivalent. And then actually for filters, people didn't necessarily like this background information, but we provide the ability to turn that on or off as much as people want. So as a summary so far of interactive data profiling. So I've shown how we can create this fast feedback loop between interacting with data and then visually understanding the results. In auto profiler, we did that by just a fast feedback with automatic updates. And then in Solos, we show we can adapt these data overviews based on history. So this idea of a more dynamic overview. But what about the actual text in our paper data set, right? This was my initial motivating example. And so far, we haven't really gotten into the details of the text columns here. So how can I better understand the title and abstract in this data set? And to do this, we need to move beyond tabular data profiling. So this is the profile of the abstract that we see in Auto Profiler. And it's helpful at a very high level. I can see, okay, I have unique values of abstract, but I can't really understand the details and answer interesting questions about the abstract. Like, what are the words? What are the topics? Because I'm just seeing that I have unique abstracts and they all have the same frequency. And arguably nowadays, understanding text is more important than ever, right? There's more text on the internet and all the documents that we have in companies. Nowadays, we're using this for AI training and fine-tuning corpora. And we also have these tools in terms of AI models and large language models that make it easier than ever to actually process text and understand it with LLMs. And understanding text requires multiple representations, which is part of why it's difficult. So for instance, if I have the conference or year attribute, I can show a pretty reasonable overview with a single chart. I can show you this distribution of the frequent conferences or this bin histogram of the years. However, when I'm understanding the abstract or title, it's not immediately clear how I want to summarize this column. For instance, I could look at the words in the abstract. I could understand that, okay, the most frequent words in this data set are data followed by visualization. Or I might want to compute topics. I could use a traditional topic modeling algorithm, or I could use a large language model to compute topics about the data. Now I can use this to overview this abstract column. Or I might want to take all my abstracts and use an AI model to compute embeddings, where now I have this two-dimensional embedding space where points that are closer together to one another are going to be more similar to get this overview of the data set. And the issue is that current systems often focus on fixed representations. So for instance, since we have a paper corpus, we could use a paper corpus exploration tool. But it's going to help us do a lot of the common questions that we might have. We can search for papers. We can find similar papers with embeddings. However, what if I also want to understand topics in these abstracts and add this new type of representation in terms of topics? Well, I can turn to a different tool. I can use a topic understanding tool, and I can see, well, which are the abstracts in each topic and what are the common words in each topic? But what if I still want to search and look at embeddings? And so the difficulty here is that a lot of text exploration tools today are very specialized and fragmented. So we can have one tool that really excels at paper corpus exploration, another for topic exploration, and another for LLM output comparison. However, there's some common core questions I want to do across all these data sets. And if I change my representation slightly, it's hard to fit this all into one tool. This means that we can have a slow feedback loop and lots of context switching between tools. And there's a lack of tools currently for quickly profiling a text data set and making sense of all these different representations, like the words, topics, and embeddings. So this brings me to the last project on texture. So first, we wanted to better understand what some of the current challenges are in text exploration from real users. So what we did is we ran this user study with 10 experts where they showed us their current workflow for exploring text with their own data. What we did is that we had each of these participants come and do a 1-hour live coding session where they showed us their task and how they currently explore their data. So we had participants from a wide variety of data sets and tasks. So like I said, we had 10 different people. About 6 of these were from a NLP or AI domain. The other were broadly Viz, HCI related, or humanities. We had a lot of people working with either LLM prompts and responses, some sort of like LLM output, others exploring, like, so for instance, this first participant was working with the paper corpus I've been demoing so far. We also had a wide variety in the structure of the data set. So everything from just a couple attributes to over 17, almost 20, and also the size of the data set. Some people were only looking at 100 documents, whereas others were looking at upwards of 16,000. So a couple of our findings from this initial session is some of the current challenges into text exploration. So the first is that people are already using structured attributes to understand their text. However, it's hard to explore. So for instance, one of our participants was looking at this corpus of song lyrics. So they had a data set with all the song lyrics and some different metadata. So we look at different representations of these lyrics to understand them. For instance, what are the frequent words in the songs? Or what are some of the phrases or engrams? What are some of the, they would calculate the sentiment. So what are the songs that have positive or negative sentiment? Or what are some of the topics? However, many meaningful questions here require linking different attributes. For instance, what are actually the common words per topic? Or what are the phrases that have positive sentiment? As our participant described, I think with text, it's converting words to numbers a lot. You're clustering, you're binning, you're counting, you're aggregating, but you can lose the context very quickly. I'd have to add a lot more code to just take one topic and then look at the lyrics for that topic. But if I could just select a topic and then say, okay, show me the 5 songs that identify strongest with that, I could read that if I wanted to. So I think that points to the tension where people are using different representations, but actually linking them and exploring them is still quite challenging. And we saw that it's difficult to explore different representations across all of our participants. For instance, they shared how they're only able to inspect a small number of documents. There's little use of document embedding. So even though this is a very powerful technique, only 1 out of the 10 people, even though they're familiar with the concept and some of them were experts in NLP, they were like, this is just too hard to use in practice for exploring my data. And we found that manual filtering is really slow and misses the nuance that they're getting when they're only searching based on keywords. So I think this points to this gap where we can develop this text profiling tool to meet some of these challenges, where we want to support different representations of the text, like words, phrases, embeddings, and quickly profile each attribute, allow people to explore across attributes and also link back to the actual documents. So we developed Texture to try to meet these needs. And what Texture does is it enables this idea of structured exploration of text data sets. And Texture is a general purpose interactive system for profiling a text data set through these different structured attributes. So there's a couple of key components of the system. The first is that we support different data sets with this configurable attribute schema. And then we have these common interactive features where we can profile the different attributes, filter them through linked visualizations, and then contextualize them by linking attributes back to the documents. And this enables a text profiling workflow. So I'm going to talk through each of these in turn. So the first thing that makes Texture powerful is this idea of a configurable attribute schema. So what we do here is we categorize each column in the data set with 5 different types. So the first is text. So for instance, the title and the abstract are conceptually items of text. The next are the different attributes. So for instance, in this data set, we have conference, where each value, each document has a single value of conference. So this is a single value attribute. This is different from list attributes, where for each document, for each abstract, we have multiple values. So there's multiple authors per abstract in this case. So this is one of my papers, and we had 4 authors on this paper. So there's multiple values. We make a distinction between lists that have multiple values with a span list, which is also a list, but each item actually corresponds to a particular span in the text. So for instance, the first entry in this word is actually a span of the abstract, data corresponds to part of the abstract, and so on. And this idea is really powerful because we can not only represent words, we can represent phrases, and it doesn't have to be the text itself. We could use a span list to represent part of speech tags or any other annotation on the actual data. And the last data type we have are embeddings. So we can use an AI model to compute these high-dimensional embeddings that encode both the syntax and semantics of the text and then help people explore with them. So with these 5 data types in the schema, this is flexible enough to represent many of the common descriptive attributes for text. Right? With text, we can represent any document or piece of text. With single value attributes, we can have single values per document, like a single topic. With a list, we can have multiple values per document. And this is powerful because we can think about the same thing, like a topic, represented in different ways, right? If we wanted a single value, a single topic per document, this would be a single value. However, if I have a list of topics, it would be a list. We could have a span list, like words, n-grams, or sentences, and then embeddings. And like I mentioned, the span list, I think, is powerful because it allows us to represent hierarchy in the document and attributes at each level of this hierarchy. This schema also prescribes the physical representation of the data. So I'm not going to talk about the super in-depth, but the TLDR is that it helps us do interactive filtering at scale, where a lot of query languages require or perform best when we don't have nested lists. So if I'm using SQL to quickly do this filtering at scale, what I want to do is take this from an unnormalized table to actually normalize this, where I split out the words, where I have a single word per row. And then what Texture does is it joins these tables on the fly to enable interactive filtering at scale. And once I have these different attributes, we can create just traditional tabular data profiles that we saw in AutoProfile or Solus. So if we have a single value attribute, I can show you the unique values in their distribution, like for the conference. For a list, I can show you what are the actual items in this list. So who are the most popular authors in this corpus of Viz papers? And the same for a span list. We can see what are the most frequent words. We can have this 2D representation of embeddings where you can see which documents are more similar to one another. And the cool thing about texture is that these are all interactive, where if I click on a certain value of a single value attribute or any of these, for instance, if I filter to the conferences or the papers that come from the conference CHI, I can see how this affects both my authors, my span list, and where this comes up in the embedding space. So as a quick demo, this texture enables us to do two different modes of exploration. So the first is this idea of a top-down exploration through these flexible structured attributes. So what this looks like is I can go and I can open this corpus in the system and then start to interact with these different charts. For instance, I can drag across this dataset overview plot and then see how this updates the different overview visualizations and actually see which documents correspond to the selection. What I can also do is I'll remove this color for a second. And I've already explored this data a lot, so I'm going to go and filter down to this bottom right cluster of charts. And then here we can start to look, okay, well, what conferences are these coming from? Or what are the frequent words? And we see that here, the top most common word is sports. So it seems like these documents might have to do with sports. And when I click on this, since word is a spanless attribute, we'll highlight where this actually appears in the text. We can continue to look at what are the authors that correspond to the selection, the years, and so on. So what we're doing is using these different structured representations to explore our data and enabling insights by filtering across them. We can also do this bottom-up exploration mode where we can really use embeddings. So what we're going to do here is search for the term sports visualization in the top left. And then once I search for this, we can compute the distance in embedding space to all the other documents. So I'll get this visualization here, which just shows what's the distribution of distances. I can then find the documents that are the closest. And once again, this cluster that we thought was sports paper is going to be the closest ones to the sports visualization. I can look through these actual abstracts to get a sense of what's the actual data going on here. If I find one that I like, for instance, this paper about racket sports, I really like tennis and badminton. So I can click on this and we can find similar instances with the same type of interaction. So once I find this, we'll compute the embedding once again, and then we'll filter our chart to show those that are the closest to this paper. So we're doing a lot of common analytic techniques here, like filtering and sorting. We can use this to do this bottom-up exploration, where I found this one paper at the top about racket sports, and I use this to find other papers that might be relevant and good for my exploration. So part of the power of texture is that it decouples deriving attributes from their exploration. So a user can decide what's the best representation for their task. They can create topics. They can derive the sentiment. They can split out words or embed the abstracts, and then pass all this data to texture to explore it in the interactive system. We designed texture slightly differently than Autoprofile and Solus, where we wanted to design both for notebook workflows, but also beyond. So in Autoprofile and Solus, we were directly augmenting the programming environment. But with texture, we wanted to allow users to be able to code to transform their text either in a notebook or in a script in VS Code, and then call a simple command and then profile these results in the system. This enables us to go from this more fragmented landscape where I have to use a single tool for looking at a paper corpus or at topics or LLM outputs to doing the common core of text exploration all in one tool, right? Where I can look at a paper corpus in texture, I can look at topics, I can look at LLM output. And part of this is enabled by framing this as a structured data profiling problem. So we're not going to get all of the unique interactions and visualizations that you get in these more catered systems, but I think that we can really get the common core here of what helps people quickly profile a text data set. So we wanted to evaluate the system. We had two core hypotheses about it. The first is that texture is expressive enough to profile different text data sets across tasks. And the next is that it's effective for actually helping people explore their data. To do this, we brought back the same 10 experts that participated in this initial baseline session, and we had them do another hour where they used texture to explore their data and then compare. So they asked them ratings questions afterwards, and then we did an interview to just ask them what the experience was like using texture versus their initial exploration. And first, we found that texture was expressive enough to actually represent all of these data sets and their attributes across these 10 different tasks. So for instance, people were able to explore this paper abstract data set that I've been showing. They were able to look at LLM benchmark outputs, song lyrics, or social media post training corpus. In survey ratings, people rated texture to be quite effective. So we asked them, did you find it easier to do the following in texture than in the baseline session? And we had collected data across these 5 different metrics. So the first was, did you find it easier to understand text attributes? And people generally agreed. They agreed that it was easier to filter to subsets. to calculate and verify new attributes, to find similar instances. And my favorite here is that people really rated, they were able to learn new things about their data set. And I think this is powerful because these people had already been working with this data. These are data sets that people had published on, they were actively working with for their research, but looking at it in this new representation enabled them to learn new things. So I'm going to talk through a couple of examples to try to provide more color to these this overview. So the first example is that we had someone looking at a social media data set. So they had 15,000 social media posts, and in texture, they were able to notice that a lot of the outline clusters here were the exact same posts. So they looked at the data overview, and they could color this by different attributes. So for instance, here they could see, okay, well, these are actually all seemingly the same author. When they would select these outline clusters, they could also verify that, okay, these are all the same author. And then looking at the actual data, they could see they were all nearly the exact same posts, or they were all like near duplicates. And with this, they were able to filter out almost a third of their data to remove these unintended duplicates. And they were using this data set to train a model. So they were able to get higher quality data and identify this issue by exploring it in texture. What they described is that texture makes me feel like I have more visibility into my data set. I'm immediately reading actual samples for like half the time, which I'm never doing in a notebook. So this shows how when we enable people to actually see their data more easily, it enables them to actually do so. The next participant here was looking at LLM benchmark outputs. So in the baseline session, a lot of what they were doing was this manual exploration of LLM outputs on two different types of tasks. So they had one benchmark data set, but it had two different types of tasks in it. And they're really trying to understand how do the outputs differ across these two tasks. And they were expressed doubt in the baseline that embeddings would be helpful. They're like, these are just too hard to work with. But when they actually put this data in texture, they could immediately see that in the embedding space, these were very clearly separated. And they could see this by the two different types of task or the source, that this color here is showing that for RIFs and S1, that these are clearly separated in the embedding space. And they could also look at the words to actually better understand what is the model actually outputting across these two types of tasks. And this is probably kind of hard to read on the screen, but one of their hypotheses is that on one of these tasks, the LLM was outputting more things that talked about the user. And we see that one of the top words in the bottom left chart, like I said, it's probably too small, is the word user. So when they saw this, they said, that's great. And the fact that it's already there, like literally all of what I did in the last meeting, you can just see here, and this is exactly what I wanted to show you. So I think what their excitement shows, right, is they're able to quickly verify their hypothesis in the actual data by using the system. So as the last example, we had this participant that I described earlier who was looking at song lyrics. So this is an interesting data set. They had this corpus of country song lyrics. And this is a very exploratory task where they're trying to understand, is there actually any useful signal in this data set about rural identity and how that's evolved over the years? We saw this participant going through both this top-down and bottom-up exploration mode, or from top-down, they would filter through different topics that they derived, through years, through keywords, to just understand their data. And then when they found something interesting, when they found one song that they really liked about hometown, they're able to use it to find other relevant songs and artists. What they described was that I think the tool, texture, was really good at suggesting new questions. Like I had some which I talked to you about in the first session, but it helped me narrow down the questions. I think this is really powerful because it's showing how it helps people explore more quickly. So in summary, through this study, we found that texture was expressive enough for these 10 different data sets and tasks, how it helps users make insights across these different attributes, and people are spending more time with the actual data. Like they described how they're actually looking at their data more. And I think my favorite thing here is that people were able to iterate on hypotheses about their data and actually learn new things just because they're able to do it in this easier to use representation. I think this shows how when we build systems that provide faster feedback, this can lead to better data understanding. Where as soon as someone is transforming their data or they're coming up with an initial hypothesis, if the system can help them verify that visually, they can better understand their data. And so we're interested in the case of texture is how could we actually speed up this feedback loop even further? So I'm just going to describe this quite briefly because this was developed after the study. But I think there's really this opportunity here to use LLMs to help people derive new structured attributes on the fly. So for instance, if I find this group of documents that I think has to do with sports, I could quickly derive this attribute by just asking the question, what sport does this have to do with? And they get back this structured chart on the right. So this looks like in the actual system. So I'll go and like reselect this group of points that we found earlier that we think have to do with sports. So for instance, these are the ones that all had the word sports in them in this cluster. So now what we can do in this workflow is then go up and then derive a new column, a new representation from this selection. So all that we have to do is paste in this question or type this question, what sport does this have to do with? And then texture will walk us through this workflow of actually deriving a new column with an LOM. So I'll ask, what sport does this have to do with? The system infers that this is going to be a single value. Then we do this prompt engineering workflow where I'm basically going to curate some examples, make sure that they're okay, preview the transform, and then I can finally run this on all of this selection. So this is only going to transform the points that were in the selection, these 42 abstracts. Once this runs, we'll have this new structured attribute for sport. And most of the values are missing because we only did this small selection. But once I reapply the selection, we can see that the most common sport, according to the LOM, is basketball, followed by soccer, followed by tennis. What I can do now is actually click on these values to see the actual documents. This enables me to do a couple things. One, I can explore my data this way. I can actually verify now that the LOM outputs were correct, right? If you recall, this very top abstract from earlier has to do with both tennis and badminton. And so the LOM labeled it as tennis. And so now this gives us the clue about how I might want to refine this query. Okay, maybe I actually want my sport to be a multi-valued attribute where there's multiple sports per abstract. You can imagine iterating in this workflow to keep deriving this. So I've introduced these three systems, autoprofiler, SOLUS, and texture. I'm going to quickly talk about what I think are some of the common principles of interactive data profiling across these. So the first is that we can just show very simple visual profiles of a data set. And these don't have to be complex charts. These can be simple univariate summaries, like this bar chart of the conference or a binned histogram of the year. But when we enable people to quickly interact with their data, can enable really powerful insights, right? Where we can click on a certain value in the conference, and then it filters all of our other charts. I think the third principle here is that we're going to make it easy to actually see the data. So we do this in autoprofiler, where we can quickly export code to see the data, or in texture, where we're linking these overview charts to the actual data. And finally, we want to think about not just how is our system designed, but where does it fit in a workflow? And how can we make these usable from programming workflows to minimize context switching? So for instance, texture is able to manipulate data in code and then launch the interface, and then autoprofiler and SOLUS are directly extending the program environment. And I think this provides the framework where we can think about how do we apply this problem to other types of data. For instance, if I have collections of images or videos, how might I profile and build a data profiling tool for this type of data? And I can imagine really using texture's approach for this, right? And I think in particular, this idea of a hierarchical attribute model, where in images, we have the colors in the image, what are the objects in each image, or the properties of that object. And the same with videos, where we might have individual frames or objects in each frame. And then you can imagine going through this interactive data profiling workflow for images or videos, where once I have these structured attributes, I can profile the attribute, interactively filter the subsets, and then use this tool while programming with images or videos or deriving these attributes on the fly with an AI model. And I think nowadays, the sort of system is really important because AI is rapidly changing how people code, right? Every day, it seems like there's a new powerful coding agent, whether it's Claude, GitHub Copilot. And I think there's this open question, what does the interface look like to understand the outputs when people aren't actually writing as much of the code, right? When an AI model is authoring more of your code, how do I understand what's being output? And I think when working with data, this is particularly difficult and important. And in my mind, interactive data profiling tools can help here because they're going to integrate into the tools where these agents are writing code, and they can help us quickly explore the outputs, right? So they're minimal enough that as an agent is quickly iterating on code, I can understand the outputs in an interactive data profiling tool to help me verify the results and then understand what I might need to prompt next. So in summary, this has been my thesis on interactive data profiling, where I've talked about the autoprofiler system for enabling faster feedback with automatic updates during data programming, SOLUS, where we can adapt data profiles based on analysis history, and texture, where we can interactively define and explore these different profiling attributes for text. So I thought it would be fun to finish with a quick data profile of my PhD, if you will. So my first profiling fact is that my dissertation says the word data 1,414 times. I feel like that guy on like the History Channel that's like data. During my PhD, I got to go to conferences in 5 different countries on 4 continents. And as Dom alluded to, a lot of Zoom at the beginning. So I'm very glad to be here in person. I had the chance to intern for 3 summers, which I think was just a super great part of my PhD, getting to work with people at amazing institutions. But every story has some downsides, and I never quite figured out how to part correctly. This is over 5 years. So that's not that bad over the years, but I got at least 13. I think there might be some missing data here. And I'm super excited that next I'll be joining Microsoft Research AI Frontiers in Seattle as a research engineer. There's a lot of people I want to thank for helping me get here today. Thank you so much to my amazing advisors, Adam and Dom, for y'all's mentorship over the years. Thanks to my committee, Sherry, Nikki, and Gagan. Thanks so much to all the Dig Lab members. It's so fun to work with you guys over the years. And of course, the people that have mentored me during internships. And then thanks for my family and girlfriend for being here today. And then, of course, thank you to all my amazing friends, people here at CMU in Pittsburgh that I've been able to spend the past 5 years with. It's been a great journey. This has been my thesis on interactive data profiling, and I'm happy to take any questions.
All right, Sherry, you're up first.
Thank you. Well, very nice talk. And congratulations on the job. I remember you like Seattle. My question is, I know like you try to use basically your work try to enable like basically EDA to be a grounding thing across all of the data science processing stages. And I definitely agree, like exploratory data analysis is super important. Always understanding your data is super important. But I was wondering, do you have any thoughts on like the nuances across different stages? For example, when would people actually prefer to have more manual exploration or like they want to write more expressive code, and when would they want more automation? And is there like a different kind of spectrum of how much exploratory data analysis they actually want to do when they are at different stages of understanding of their data or processing their data?
Yeah, I think you really hit on it there in my mind, that it is a spectrum. I think I'm looking at the owl, but I think the spectrum's important, where I think when we can have these automatic tools, it helps us get these initial overviews more quickly. And the goal, I think across these systems, whether it's like auto profile or source or texture, is to help people notice initial things more quickly that they might want to follow up on, right? They might want to follow up on through code, through a custom visualization, maybe even through another interface that's really catered to digging into the details of a topic, for instance. But I think if we can have this layer of tools, of interactive data profiling tools that automate this initial step, it helps us catch things that we might not have even thought to check for or drill into more if it hadn't been shown. Like, I really like this idea that someone talked about in the auto profiler study of serendipitous discoveries, right? Like, I don't know to look for something, but when I see it in the system, like, oh, that's weird, or that fits my expectation. And then when I notice that, then I can drill down further, whether it's doing code on my own or using another system. Does that answer your question?
Yeah, that does. I guess a follow-up question is like then how deep do you think the like auto profiling or like in situ data profiling have to be? Like if, for example, most of the auto profiling right now seems to be on unidimension. Basically, it does a bar chart for this particular column, for this particular like title or like conference or whatever. Do you feel like that might have like any kind of backfiring effect of like making people focus a little too much on single variables and do not dig as deep into, for example, correlations or some deeper relationship between the data? And like, is that something we should support more, or is that something that we basically should still leave it to people because we want to just offer the first layer of feeling like there's something wrong in the data?
Yeah, that's a really interesting question. I think there's a couple aspects in my mind. One is like, what do we actually show someone? And so I think that there's been this interesting evolution in the past couple of years where we have very powerful AI models that can understand semantic concepts. So I was super doubtful for years of systems that would show people insights, right? I was like, I want to build a system that shows you a representation, and then the user can decide, is this an insight or not? Like, I don't want to just tell you, okay, here's 10 insights in your data set, because I think it's hard for me to actually know, is this valuable or not? For instance, if you show me this data set, I've looked at this abstract data set so many times. If you told me, if an AI agent told me there's 6 conferences, I'd be like, yeah, like, duh. But if you never looked at it, I think that can be valuable. So I think there's one side of this of like, what do we show someone? And can we potentially move in this direction of trying to like automate that even further? Like find useful, meaningful insights for the task, and then present that to someone. I think there's like potentially space to do that with AI models. I think I didn't always take that approach in these systems where I was like, let's show someone just a simple overview that's very easy to understand. It's predictable, right? Every time I use texture, every time I use auto profiler, I'm going to get the same representations, which makes it faster. Like I know what I'm going to get. And so now, like for instance, I mean, I built this system, so I'm probably biased, but when I use auto profiler, I know what it does and what it doesn't. So if I want another type of overview chart, then I know I'm not going to get that in the system. But for a lot of these core questions, I think we can answer that. So I think there's a spectrum there, right? Like we could show people more information, but then you start to get in the space of potentially overwhelming people, where if you show them, I think a big aspect here is speed. And if the system enables you to still quickly look at the results, then you can look at other things on your own. And if I have like all this information, I think I found before starting this that a lot of current tools which show too much information, and then that's actually slowing you down rather than speeding you up. I think the last aspect is I think there's potential. You don't want to instill people with a false sense of security. Like, oh yeah, I looked at my data, there's no issues. Right? Because there can be these very gnarly issues that are like very, very small slices of the data set. I think that's a concern. I'm trying to think like what the best way to, I think part of that's like an education thing. Like if I know to look for that, like I think that the people that have like audited a lot of AI models know what to look for. And so they might know that, okay, I could find some of these issues in a data profiling tool, but some of these other ones, I know I need to go use a custom tool for. So I think that's the sort of thing that like is going to be outside the purview of the sort of interactive data profiling tool.
Yeah, that's
Or
a
you
great,
start
great answer.
making the rounds.
Actually, I would love to use your tool for the like mini data science course I was teaching the PM people. I think they really
Yeah,
need that because coding was really hard for them. That's all my questions. Great answer.
great. So Gagan then?
Okay.
Great presentation. Well, so theses are a great time to make connections between the different works that you've done. And I was curious that given your work on texture and AG debugger, what are sort of your current thoughts on how can we help practitioners effectively profile corpuses, really large corpuses of LLM reasoning and action traces? I mean, you did a lot of work with AG debugger too, but given all the new things that you've learned with texture and all the principles that you came up with, what's sort of your current mental model of how we can help?
Yeah. Yeah, so AG debugger was a separate system that I didn't have in today's presentation, but for debugging agents. I think the one concept that I like the most is this idea of a really fast feedback loop between asking a question in natural language and then using an LLM to derive that. Like I really like how it's hard to change the sides of people, but I liked how when you can ask a question using the LLM in texture, I'm not just going to get a chat response back. I'm going to get a chart. I have this structured representation where I can look at the papers that have to do with sports and actually get back, okay, these 9 have to do with basketball. These 6 have to do with tennis and so on. And I can imagine that sort of approach being really useful if I have these long agent outputs as well, where I might want to know, okay, how many times are these agents repeating the same task? How many times are they trying to access something on the web page that's not there? I think extracting that, I think the extraction piece there is perhaps more difficult, but if we could get to that sort of interaction, I think it could be really powerful. One, for letting people do this interactively. And then if we notice, if you have some sort of taxonomy on common failure modes, then we could start to extract that automatically as well.
Are there any challenges about scalability of these approaches that you'd be worried about? So for
For sure.
instance,
Yeah.
if a corpus of these reasoning traces or agent actions are, let's say, in the orders of tens of thousands of these,
Yeah.
and you're really trying to narrow down what is the next fix I need to make, what's the biggest issues, what are the most common failures? Like, are there any scalability issues that come to your mind that you think are still open challenges?
I think scalability in general is an open challenge. I think there's perhaps two aspects of it. One is the scalability of computing the representation. So for instance, in the current form of texture, I map every document, like I pass it through an LLM and then get that output. That's pretty expensive, especially for a simple question, like what sport does this have to do with? I probably don't need to use like an OpenAI model for that. That's just kind of the easiest thing to prototype. So I think there's like the runtime scalability there, which as you get longer documents, right? As I move from paper abstracts to like full 10-page documents to something that's like a very long trace, I think it gets harder to actually map that. And I also might want to map not the entire, I think there's this aspect that can be really powerful that I'm not totally sure like how it would look like, but on only extracting things from individual segments, right? Like if I took my whole thesis, like I take this 100-page document and you're like, show me the areas of this that have to do with paper abstracts. Like I don't want a summary. I don't want like a single thing. I want to map the individual portions of that document. I want to map the spans. But so I think doing that at scale computationally is challenging. And then the other aspect is trying to figure out how to help people make sense of the output. Where as I map more of this stuff, I'm going to have more issues to deal with, just like more things that get flagged. And then I think that's where interactive systems can help people like provide like easy representations, like in a data profiling tool, but help them try to really flag the most pertinent issues and summarize the outputs to then know, like, what should we do next? Does that answer your question?
Yeah. Thank you.
Cool. Do we keep going?
All right, yeah.
So this was great. I really enjoyed it.
Thank you.
And I want to sort of dive into really like some things that seem more maybe more philosophical than trying to attack you as Don was trying to get me to do. So I guess the first thing that I noticed with all of these systems is that they seem very carefully designed to avoid kind of taking a perspective or like, putting a perspective on someone from the data. So, if I was to think of like how Adam might design this tool in his youth, it might have been with mixed initiative clustering or something like that, right? Or maybe there would nowadays would be more kind of LLM based like analysis and synthesis of the stuff that's in there. So it seems like you've very intentionally decided to kind of stop before that point. And I'm, even in your embeddings, for example, you're showing them on the on a 2D projection, right, as opposed to trying to do some clustering. And your example of even how you would use an LLM for the sports example was kind of like, okay, let's just take this and sort of split it into more things. I might even go as far as to say, like, is this kind of like focusing on the foraging side of sense making? And is there like, the actual sense making part? Like, do you think, and the synthesis part, do you think we shouldn't be helping there? The tool shouldn't be doing things like, what were you worried about? Why did you choose more around your design rationale?
Yeah.
Why did you choose to create tools in this way? And do you think like if you had more time you would work on that, or do you think there's things we should avoid that are dangerous in some sense that are why you chose not to?
Yeah, I think I like that question, and I think that it like was an intentional design choice. I think I'm doubtful. I think the farther we push from this like foraging side into like I called it insights earlier, but you could think about like, okay, showing someone insights in their data or showing them like the actual synthesis, the more doubtful I get that it'll like the tool will actually be helpful or it'll show you something that's real, right? I think the good thing, like these are often very simple representations, and then I leave it entirely up to the user to decide like, what does this mean and what do you do with it? And I think the benefit of that is that it's probably a double-edged sword, but it's super domain agnostic, right? Like we show we can use texture in a lot of domains, like Autoprofiler and Solus are really just looking at data as tabular. They're not saying this is medical data, this is financial data or so on. I think that there's a potential to like try to do more of the synthesis, but I think you just need, in like the LLM parlance, like you need the right context. And so I'm fearful that we could show you something about the data set that would say, oh, like, look at this amazing insight in the data where 55% of your rows do this. And I think it's hard to actually know like what someone has, like for the system to know what does a user have in their mind. They might be like, okay, yeah, that's super obvious. And like I've seen other types of data profiling tools like this that try to do that. They'll show you like facts about their like fact extraction. And I don't know if it's always done in a principled way, where like we're kind of showing you potential things in the data, but it's, I think, up to the user to decide, like, is this actually insightful? Is this an error? And then like, what do I need to actually see to convince me of that? I think it's an exciting opportunity. I just think that it's hard to do well to a certain extent, where like, it maybe to caveat that, to do well as a generic system, right? I think that like, perhaps if these tools were designed in a more specific domain, we can really map the questions that people have more precisely, right? Like we know that, okay, if someone is only looking at paper abstracts, like my example, then they're probably going to have these 5, 10, 15 questions. But then it's harder to use that tool, like I alluded to, if I start to add in other representations, other types of data, they can be valuable for the task, but like that tool wasn't designed for. So I don't want to like totally close that off, but I think the appealing part to me about this approach is that we can try to do this sort of initial step more quickly for people to like save them having to spend time specifying charts, like manually actually finding the information that they need so that they can focus on the synthesis step, but do that on their own, not in the tool necessarily. And it's a blurry boundary, I think.
But thanks you for articulating that.
Yeah.
That's interesting. Based on that, I'm going to choose a follow-up question, which is that approach. It feels like one of the trade-offs is that you're generating a lot of data and things for people to interpret and, you know, make sense of.
Yeah.
And I'm wondering what, you know, if I was to ask you, like, given that, what principles do you think you could take from these tools to kind of less researchy settings, like more practical, you know, settings and companies, right? Like a lot of the things you were doing were texture user studies were with like NLP researchers,
yeah,
data viz researchers. And the data was often very new to them, and like, you know, okay, a lot of data they were exploring. If you think of, you know, like a typical real world example would be, you know, hey, like my sales of this new model of something are strong, but they are declining in Arizona. Like, why is that? Like, maybe I look at the service records and the sales records and the social media posts. And so, and the people who are doing this are probably not like expert data scientists either, right? Like you want to be able to kind of interrogate your data. And I'm curious whether this like fast feedback idea, how could you help them? Like, I'm not sure they would be able to even really understand or interpret or know where to look for a lot of the things you would show them that are first order sort of descriptors of their data.
Yeah.
But maybe that same idea of fast feedback could be still adapted to something that was useful.
Yeah.
I don't know. What do you
Yeah, I think perhaps there's two aspects. I think the fast feedback can be helpful as people, and I think a lot of fast feedback here comes up. I mean, all of these were very, as you alluded to, expert targeted systems. So people that, I mean, like myself, that like really live and are comfortable like programming with their data. They're like, I don't necessarily want to use something like Tableau that is more like a generic user base, but that for me to answer a very specific question, like I could just write code to do that. So that's why I'm like, okay, we want this fast feedback between an expert programming and then the system showing you this overview. So I think that if you have someone with less expertise, then that programming aspect starts to disappear. I think that these data profiles can still be helpful, but like there's a lot of things that these systems intentionally choose not to do. Like a lot of ways, like for instance, with the exception of the like kind of small LLM transform feature, like you're not transforming your data in the tool. Right? Like I'm having to generally like remove like all these million different ways that I might want to aggregate, transform, like create new columns. I'm doing that in these systems in code and then looking at the results in the tool. I think if you have someone that's less experienced, like it's harder, they don't know how to code to do that. And so I think they still have those needs, but then you have to just build a lot of features in one tool. But I can imagine, and I think there's already been like more commercial tools that like were inspired by this, and like vice versa, that I think we took inspiration from to like help people do that in especially like a SQL setting, right? Where like SQL is maybe easier to write than like a full Python script. And so someone that doesn't necessarily have the experience can write SQL and then get fast feedback. And like there was a company called Rill that we took a lot of inspiration from when doing auto profiler. I mean, arguably that's still, I think, like expert focused. So I think this is a really interesting question because there's like this whole population of people that like need to, should work with their data. But I think that you have to build a lot more features in the tool. And I think this is where a lot of the traditional commercial applications go, where you have to build all these features into the UI. Where like I think getting faster feedback and having minimal overviews there can still be helpful. But I think the grunt of like the development work there is like on stuff that's almost entirely outside of these systems, on just like letting people manipulate their data. And then you could like plug in a design similar to this to help them understand the results. So yeah, I think that's an interesting, I think, follow-up, because I think there's a lot like it's almost like a whole different population to think about how would we adapt these sort of systems to. So
Great, thanks.
yeah, thank you.
All right, I maybe a little bit of a follow-up, a high level question and an extremely low level question, but they're actually connected.
Okay.
So in your, I think I've asked questions about your systems for the last 5 years. So following up a little bit, one of the things you really described in your introduction of the thesis is around how EDA these days is, looking at data, writing code, and how these two are really, really close together, where you're not just writing some code and then looking at some data. Really, this has to happen all the time and really in quick succession. And a lot of code that you write is kind of very ephemeral. Just write it quickly. It's not like code that stays around for a long time. And so that seems to be like perfect use case for LLMs to generate code for you, right? Because it doesn't have to be perfect, and there's a lot of boilerplate and so on. So what do you think, now that we have more LLMs becoming more and more prevalent, what are the things we can take from what you've learned in, for instance, Solus? Solus looked at a bunch of code. That's what LLMs do as well. Do we still need Solus? What have we learned from Solus that can maybe be applied to like LLMs? And maybe to go a little bit more also in this automation direction on the spectrum of full control to automation.
Yeah, I think that's an interesting question. I think there's a couple aspects. I think the approach in general, like I alluded to, I think at the very end, I think these can become even more helpful if I'm not writing any of my code. Like if I'm just totally vibe coding and I'm like, okay, well, like my agent write all my code for me, analyze this data set. Like I need to understand the final output and then probably intermediate steps as well. And so I think that like having these sort of tools, even if I'm not the one typing out the code, like I think they can still be very useful for like helping people understand and deciding, like even if it's like hands tied, I'm just like dictating code. But if I can see the outputs and then see this and say, okay, actually, like it looks like there's still missing values, I fix that. And you can just prompt that. And so I think that like the general approach I view as complementary to how people are writing the code. I think the more specific aspect of that in Solus on like I think the task specific part to me is more interesting, and I talked about that more today, right? About like if you're doing a particular task or if an LLM is writing code to do a particular task. I don't know if I don't know if the needs change that much if like me as a human, I'm the one writing the code, or if an LLM is producing it. Because I still need to like understand the output of that code. And I think like that output understanding is what these systems target. And I don't know if it fundamentally changes that much, even if an LLM is the one authoring the code.
Yeah, I guess one thing that's happening with LLMs is that you don't have the like necessarily good guidance in them anymore, because they kind of do things, however, like that wasn't a training data. But they're not necessarily following best practices like you did with carefully designing the behavior of like Solus.
Yeah.
How can we bring this like careful design into these data data powered tools like
Yeah. I guess I was thinking about it more from like the human user perspective. I guess a totally different perspective is like, how do I make my LLMs really good at data profiling? Because like arguably, like that's very important to people that they understand their data, that they're looking at results as they're going.
Right.
And like if people have used like Copilot and stuff, oftentimes like in a notebook, it's still like it'll make up a column name or something because it's harder to link the code to the data. So I don't know if this is actually what you're asking about, but it's kind of, I think, an interesting idea on like, what does it look like to give my LLMs data profiling tools so that they're also looking at their data as they're generating the code? And I think that could maybe help you get better quality outputs. I mean, I took that a weird direction. I don't know if that's what you're asking about or.
That's kind of what I'm asking about. If you go to slide 43, I know it's a little tricky, but looking at that example that you gave there, it was if you filter to more than 100 citations, then there's no Chi or Eurobis papers.
Yeah.
And maybe it was, yeah, that one.
It's on the left.
On the left there. I'm not sure whether they have it somewhere else as well. Maybe I just got the wrong slide.
Yeah, it's on the right chart.
So is that, do you think so is that maybe happening because there's no citations for Eurobis and Chi in your data? So it's not actually that it's more than 100, but it just happens to be that you see this insight here, but it's actually true for all papers. So if you had citation count greater than 1, it would also, like, there's basically nulls for Eurobis and Chi in this data.
Oh, I see.
Could that be the case?
Very well. But I think
And could an LLM help you maybe detect this kind of like limited, you make an insight, and rather than like, an LLM just giving you random insights, it gives you a verification of maybe an insight that you made. Because you said papers over 100 citations do not exist in Eurobis and Chi. And LLM could be like, actually, it's because nulls.
Yeah. No, yeah, that's interesting. I hadn't thought about that as much. I think to me, what that would require is like you basically have to verbalize your insight. Like I have to say concretely that I think this was you're probably talking about. Like I need to write out, like, and you can imagine a system or a way that I just write out none of the top cited data of this papers come from Eurobis or Chi. And then there's a lot of aspects of this, right? Like I alluded to, like I just might not have the citations from those conferences. Or like this data set could be incomplete. Like especially for people here that know Chi papers, this is kind of a weird fact that like none of the top cited Viz papers are coming from Chi at all. So this seems like an issue. And I think that Solus is helpful because it can help us notice this weird thing and then inspire us to look further. So like inspire doubt, right? To be like, okay, I'm noticing this, but that doesn't seem to be true. I think it's actually an interesting idea, right? Is if I say this, and like this maybe even connects to what some of Nikki was asking about, if someone that like hasn't spent years, a lot of time looking at data, if they write out this insight, they're like, oh, look at this crazy fun fact that Viz papers at Chi are terrible. And you're like, oh, actually, like your data is bad. Like, and the LLM could help you figure out that like there's potentially 100 causes of this fact.
Yeah.
And many of them could just be bad data.
Could be very generic things, right? It doesn't have to be a super specific tool.
Right.
It can still stay generic.
Yeah. So I think, yeah, that's interesting. I think that's maybe a different aspect of the kind of, I think, automation part on like this. And I think this idea of verification ties in with a lot of the other tools, right? Like how do I kind of quickly verify outputs or the insights that I'm making? So yeah, I think it's an interesting idea.
All right. That's all my questions.
Well, yeah, first, I mean, a great talk. That was like delightful to kind of see this clear narrative arc of, what you've done over the past 5 years. So it's really good to see. You can also hear most of the questions have to do with LLMs, which of course didn't really exist when you started 5 years ago, right? At least the level they're now. So I guess, yeah, some of my questions kind of build pieces of what, Dom and Nikki and Sherry and Gagan have all kind of asked. But again, there is this clear level of automation in your tools. But again, this automation was really carefully crafted by kind of you, an expert in data science and visualization, kind of grounded in kind of statistical and visual properties. And I think, again, this kind of differs from this kind of new reality where we can just ask an AI model, show me an overview of this data, and you'll get back something that might look somewhat similar to what you design. You might get a bunch of histograms or whatever, but it won't have this kind of thoughtful curation that you really put into what to show, and therefore qualitatively it might be quite different. So I guess like thinking at a high level, how would you advocate for someone to use tools like yours versus what's easier to just say this? And I don't know, just thinking about that.
Yeah, no, I think that's a great existential question. I think one aspect that I really like, and when we ran the autoprofiler study, I feel like that's right when they weren't nearly as good, but some of the LLM coding tools were coming out. And I think that I think there's two aspects. One is learnability, right? Like autoprofiler, like these representations are always going to be the same. And I said this a little bit earlier, where I know what I'm going to get and what I'm not going to get from autoprofiler. Whereas if I ask an LLM to profile my data, I'm going to have to very carefully inspect the output because I can't predict precisely what I'm going to get every time. So I think that there's this learnability aspect that you can get in like custom design tools, but I think this is also why like keeping them minimal is really beneficial, right? Like I think showing something minimal, like so I know what I'm going to get, and then I'm probably not going to get like all of the like crazy chain of thought that an LLM would give me, but at least I know like, okay, I can turn to this tool and then give me this fast feedback where, and I think a lot of it is like so I think that's probably the first answer to your question. And I think also at the workflow level, it's interesting where like, as I'm programming, the system is like not necessarily, I could, but it's not necessarily having to make LLM calls every time to reprofile the data set. And so I don't know, maybe in the future, like these days, the near future, like LLMs will execute just as fast as pandas. But until we get there, I think that like having these sort of like more minimal systems to really get fast interaction speeds is still very powerful. But I think they're complementary. Like I think at the end of the day, like I'm going to be like shaking my fist at the sun if I say that don't use LLMs for your data science. So I think it's very complementary approaches.
Yeah, so I'm happy to. I've asked you a lot of questions the last 5 years, so I'll yield my time now. But do any of the other committee members have repeat questions for another round before we go to the audience?
Any on Zoom from Gagan or Sherry?
Can it open it up to anyone in the room or on Zoom?
Then Kat.
Yeah, also, I had no shortage of opportunity to ask some questions, but great talk. First time I'm seeing it all the way through, and congrats on the next thing as well. I wanted to ask you about trust, because I don't think that you said data 1,400 times. I didn't hear trust a lot, right? But we've talked a lot about trust in the lab, and I'm kind of curious, like, did trust come up in any of the user feedback? Like, how do people think about trusting what your systems are giving, especially as they're more automated? And like, are they thinking of it as like an AI system, or are they thinking of like trust in like a chart? Because people think of like trust in data visualization a little differently, I guess. Yeah,
that's it. I like that question. And it's funny because I don't think I've like thought about it that way as much, particularly because these systems are not, I think as soon as you're showing someone like an AI insight, then they're going to be like worried about trust. But I think this came up a couple of times. I like ad hoc remember over the years in a study where like kind of like this insight that Dom was just talking about. Oh, you can't see now, but like where you'd like I show you that okay, like none of these papers are from Europe or Kai, and they'd be like, all right, well, like is this actually true in the data, or is your system broken? And so I think like that's kind of an aspect of trust, right? When you show someone something about their data that's not intuitive or that doesn't meet expectation, then one, like, I want to make sure like, my system's actually working, but then like you need these ways to like help people develop trust. And I think that's particularly important as you move towards more automated analysis, more automated insight, right? And I think that these are at the beginning of that spectrum where we're just kind of automating the presentation. So I think that people are more willing to trust it. And then they have these, I think of them as escape hatches where like, if you want to ask the follow-up question, I can do that back-end code. We'll help you write that code. But I think that becomes more important, and then you need more ways to like, it's kind of like, I think it's coming up with LLM as a judge research right now, like kind of verify the verifiers. Well, if I'm like using an LLM to verify my insights, how do I verify the LLM that's verifying my insights? And then like you have this cycle. But I think that like, as much as we can show people where this is coming from, it's like citations, right? Like if I could show you where this insight's coming from, then you'll have more trust that it's actually grounded in the data and not a bug or a hallucination. But I think that's like, I feel like it's like almost in my mind, linear relationship between the more automated you get, the more like of a concern trust becomes. Or maybe it's even like, I don't know, just kicks off like a hockey stick, but it's an interesting question. Yeah.
Hi, first, thank you, very nice talk. I want to ask you a very high level question. You also mentioned that your research could potentially be applied to the how to utilize the video data. The point is currently, I think the scaling law is hitting a wall because people almost run out of all the like internet data, but to utilize the video data is pretty difficult. It's pretty noisy, and it's sometimes very hard to control or curate the video data. I wonder what's your thought on it?
Yeah, so I'm gonna just like lead that I'm speaking totally out of pocket, but I think to me, the exciting thing is that I had this evolution from like working with structured representations to text, which like requires, I think, these different representations. And I think it's exciting to me to think about how could we apply the same approach to videos or images. I've never worked with videos, so I'm kind of just spitballing here, but I think that the general idea is that if we can have structured metadata about the video, and like off the top of my head, it seems like I could have like what are the objects in this video? Like what are in each individual frame, I could have like what are the people or like the concepts. Then I now have a structured representation that we can use data profiling tools for. And so now I have this way to like basically navigate the video to say, okay, show me all the segments that have people in them or dogs, or show me all the segments that have a light color or a dark color. I think actually building that would take a lot of engineering effort, which is why like I didn't do that. But I think like the core approach here of like if I can take an unstructured data set, get a simpler to understand structured representation for images, for videos, could enable me to build this kind of tool and have a way to navigate the data, right? And I have this like way to kind of go to different parts of the video to summarize. Like if I just have a video, and like you could have it imagine like a parallel corpus of like the video with the audio with the transcription of the audio. And I say, okay, show me all the times in the video. How many times does the word data come up, right? Show me all the times in the video that the word data comes up. So I think like I said, I think there's a lot of like technical difficulties there, which would be fun to think about, but after the PhD. But I think having it as a structured problem enables you to use these very familiar interaction techniques, like filtering, going to parts of the data. Does that answer your question? I think it's a really interesting.
Yeah, thank you.
Thank you. Wesley.
Yes, amazing talk, first of all. The most impressive part is that you only got 13 tickets. It's based on where you parked. But I guess the real question is, how many of them did you actually pay?
All of them. I'm not getting.
Okay, yeah. So I'm gonna ask a question that John Zimmerman usually asks, but he's not here. I guess you guessed it, because we all know that you're pensioned on doing a startup company. So my question is, if you would pick one project to do a startup company, or in a certain way, right? Which one would you pick? How would you do it? And who do you think will pay for it?
I think texture has the most nowadays commercial application, right? I think that we have a super developed ecosystem of tabular data analysis tools, right? I think it's just so hard to compete, like to make programming tools better and sell them, competing with Databricks, Tableau, all these. But I think that right now, like since we have this amazing new ingredient of using AI models to understand unstructured data, whether it's text or like videos, like we were just chatting about, I think that there's a lot of potential there on like trying to actually get these things in people's hands. I think there's like the maybe non-research but interesting question of like, at what point I think that like we need people to want to look at their data. And I think that like I've hopefully shown some examples of like when that's beneficial. And I think like, you get better understanding, you can find issues, but I think people have to be motivated to do that. And we have to find a way to be like, okay, like if you use texture, then you'll save $10 million. Like, I don't know. I think that's harder to show. So I think that would be, but I think just kind of this direction of like helping people understand, use unstructured data sets, whether it's curating them for training models, fine tuning, or for just like actually interacting with this data across domains, I think could be a really powerful direction. Thanks, Wes. Diego.
Very nice talk. From a theoretical background, it's actually mind-blowing how useful the research is. I wanted to ask you the following question. It may be a bit orthogonal to your contributions, but it seems that in texture, you exploit the embeddings mainly perhaps in these 2D projections.
Yeah.
And my question is, how satisfying are these 2D projections you're experiencing? Meaning, I would assume you go from these like high dimensional embeddings to the 2D summary of such embeddings.
Yeah.
And in doing so, you presumably use a bit of information. Is it usually satisfying? Like, do you usually find the 2D projections of the embeddings satisfying?
Yeah.
Or, and following that question, do you think there's room for some other housing, visualization of these embeddings?
Yeah, I think just to show what he's talking about. I was this huge hater for most of my PhD. Almost every data viz paper these days has a embedding projection. I was like, these are stupid. But then I put it in and I was shocked how useful they are. And I think there's a couple aspects that made it useful. One is that we kind of wash our hands of how they're computed in texture. The user provides the projection. There's a million ways I can project, right? And actually, I mean, like Venkat had a paper earlier in his PhD on like looking at the differences in these projections. So in texture, I'm not computing this projection. I'm like letting the user do that on their own. They could use TCNE, they could use UMAP. So they can decide, and like you could imagine someone computing different projections and then exploring it and trying to like get a sense of what's going on. Because I think that's a very challenging problem, right? It's like, how do I actually get a good 2D representation? And I think the good thing is that visually, it's always going to be represented as a scatter plot that you can mostly see. But I think computing that is challenging. So I was like, I think that should be outside of the system. I think what made it useful and like surprisingly useful to me was linking it to these other attributes where I can like find this little random subset in the bottom right and then look at the words, look at the authors, look at the documents, and then have an impression that these have to do with sports, right? Or like, and that was a very specific example, but I think like you can color this by the different attributes. I can kind of see that like, okay, the far left is Chi papers, the bottom right is Viz. And I think it helps you make these sort of nebulous ad hoc observations, but that are very characteristic of exploratory data analysis that I could then have an idea of like, okay, it seems like these things are differing. Maybe I want to go verify that later on. Like, I mean, the initial formulation of EDA is that I can make these initial hypotheses so that later on I can go do confirmatory analysis to actually say, is this real? But yeah, I think the TLDR is, I think I was surprised. And like people in my user study, I think use them so much more than I thought. Like they would I mean, maybe it's just like the screen location, but I think having this like nice summary of the data set can be surprisingly helpful, especially given what I think many of us know about kind of the finickiness of embeddings and projections. Yeah, thank you.
Andrew has his hand up and then.
Yeah, who's the other question?
Yeah, fantastic presentation, great PhD. I'd, seen a lot of the work. It's great stuff. The question I had to do was with more of like linked data. So you can imagine, right, like you're looking at text, but now post LLM, like this text also has citations in it, right? And it has citations to other data, or it's a not necessarily a picture, but some kind of thing that references a thing that might reference a thing, right? So how does, which again is more relevant if you're like, have a bunch of LLM outputs, right, that have citations to stuff. And you're trying to review this type of stuff. So I guess how with these systems, I'm seeing a lot of like, the more flatter data. So how, I guess, are you thinking about, these things that are a little more linked or might, be, as you mentioned, a little more hierarchical? That's my question.
Yeah, I think we support in texture at least the initial steps of hierarchy fairly well. But what I think you're pointing to, which is I think comes up, which is like a very real analysis question, is more of like a graph model, right? Where I want to go from document to other documents that are like citing that one. I think that would take, there's been like prior work on exploring text data sets in that way. In particular, we don't really support that well. And I think like trying to force that into texture would just be messy. I think that could be very valuable. And I mean, that's almost like its own field of research on like graph exploration and like these links, because I think it like is harder to summarize in this way. But I don't know, maybe you could like add in some sort of like graph overview. But I think just the structure of the data is quite different. So to answer this sort of questions, like for instance, to be concrete, right? Like right now in texture, I could filter to a certain author. I could find like certain sets of authors. by looking at the data, but if I wanted to ask this question, like, show me all the authors that are 3 degrees away from myself, that would be hard to express in the system. And I think you kind of need something that has more of a graph-based data representation.
Thank you.
All right. Any last questions? Otherwise, thanks again.
Great.
Cool. Let's stop the recording. And I'll have to ask everyone except the committee